Hello, everyone. Welcome back to SAT Math Question of the Day with Professor Emeritus Seth Chaiken and Seth's brother, Joel, here. We're here to hopefully show you how to approach SAT math questions, many math questions. Here we have an SAT math question from an older book, but it could be seen, I think it could be seen on a modern test. Modern meaning post-2016 when the SAT changed their tests. Today is Throwback Thursday. Welcome to Throwback Thursday. On Throwback Thursday, we truly go back to a previous test from 20 years ago, practice tests, and show questions that really have no chance of being on a modern SAT. So let's get going on this one. It's question one on the, particularly on the older SATs. Question one means easy. They always put an easy question. They always used to put question one as really easy. Sorry about that. Okay, everyone, please read it and try it and come back, and I guess we'll do it, right? If this expression is, if they give you an expression of A's and B's, and B is 1, what is the value of A? So,
all right. Well, this looks really hard because it's so long.
Okay.
But this is easy, not because of the principles or for solving an equation for A, but because of the pattern.
Right.
So I'll show you how my eyes found the pattern. I looked at the equation and saw it's a single linear equation with two variables, A and B. And then I saw that they tell you what B is, and the question is to solve for A.
Right.
So here's what I did. I thought about plugging B in. I put these two things together, and what I saw was 3 minus 3, because I put the 1 for B, which is 0. And then the whole thing equals 0. And the left-hand side is 1A plus 2A plus 3A. No constants, a bunch of A's. Bunch of A's added together are 0. Well, the only way that could happen, A plus 3A plus 9A, bunch of A's equals 0. The only way that could happen is when A equals 0. Answer. I notice I did not think of adding 1 plus 2 plus 3 to get 6.
Right, because you will.
So if you're not sensitive to the pattern, what you would do is write, from the left-hand side, you would simplify this to 3A. Right, that equals 0. And then to be pedantic, you use the law of algebra that you could divide both sides by 3, because 3 is not 0.
It's actually, and you get 6. It's actually 6. It's actually 6.
Yeah. See, that even 6. Yeah, you're right, 6. 1 plus 2 plus 3 equals 6. 6A equals 0. Divide by 6. No, that is not a good approach. You just see a bunch of A's. So it's not a trick question where they gave you a bunch of coefficients that add up to 0. A more sophisticated question would be something like this. Suppose you have 3A minus 2A minus A equals 3B plus 3B minus B. 3B minus B, right? B equals 1, so the right-hand side is 0, and the equation simplifies to 0A equals 0, and then the 4 choices are A, B, C, and D. 3, 9, minus 15, or 6. Well, any of the choices would be right then.
Yeah, but that's not.
But that is not. That's not the tricky singular kind of equation that is going to be a question one.
Right. Yeah. Yeah. Yeah.
Okay?
Yeah. Yeah.
So this is a case of getting a quick solution by observing a pattern.
Right. Right. But yet again, it doesn't hurt really. You don't lose that much time. Let's say you don't initially see the pattern. You add these up and you write 6a equals, and then you put the b in here. 3, then you get 6a is 0, and then you realize a is 0. It doesn't hurt to do that. It doesn't take that much more time. But what this question does is it does boost one's confidence in taking the test.
Yeah.
The last thing you want to do when you take a test is have a really hard question as question 1. So at least you say to yourself, "Oh, at least I got one question right," which is a nice thing. Again, this has the flavor of an older test. But also the older test, all SAT tests are really into patterns, and this one's real, and you really see it here. That there's these.
Yeah.
So I guess there's not much else to do. You just sort of substitute in for B and basically solve the equation in one way or another. So do it the way Seth did it, which is basically to see the answer, or to be a little bit more methodical. So, okay, but it's a linear equation, and you just so the ideas of substitution and combining like terms apply. In algebra, substitution is very important, and combining like terms is very important.
And it's important to not mix up your A's and your B's.
Right. Well, that's the whole. That's right. Yeah. Okay, so that's it for that one. I
wonder if one of the distractors is mixing up A's and B's. So if you say let's just try that 6 equals 3b minus 3. In order for that to be 6. B has to be 3, and the 3 is a distractor.
Right.
So they have a choice for people who make that mistake, mixing up the A's and the B's.
No, wait a second. Yeah. No. You got if you add up the A's. If you say A was 1, then you get 6.
You have 6 on the left hand side.
3b plus 3. You add 3 to both sides. This is 9 is equal to 3b. B is 3. Oh, you're right. Yeah, B is 3. Okay, you're right. That was a distractor. Okay, so now we're going to move to a question from the same book, which was from 20 years ago, from official SAT questions, which really you almost never see this, or you never see this anymore on a more modern test. It's a big, long question, tall. So,
well, if you build a time machine.
Yeah, if you build a time machine. So this is question 9. So they give you the shape. In the figure above, the 3 diameters divide the circle into 6 equal regions. So there's like different pizzas. If the circle is rotated 120 degrees in the clockwise direction, it's in its plane, which the following represents the resulting circle. This almost looks like more of an IQ test question than a thing. Yeah. So now we have to reveal the questions. We have to reveal the answers.
We have to have all 5.
Yeah, we have to. Yeah, it's 120. Yeah. Now remember, it's 120 degrees.
Yeah.
So let me write that just so that it's really in our faces. 120 degrees.
Yeah.
And it's rotated in 6 sections. So I guess we need to think this through, right? So 120 degrees.
Well, 120 degrees is that's you have to I don't know what's 120. It's a third of a circle. It's a third of 360. Or it's 2 60-degree rotations. Okay? So what I did was it starts out with the dark thing is on the left. So you rotate it 120 degrees. What happens is the guy on the left-hand side gets dark. And so it's either this one or this one.
Yeah.
And which one can it be? Well, that's easy to tell by observing first that all 4 of the little sections has a distinct symbol. So you just have to check which one matches. So you bring your eye up to here. The This dot, the dot is going to go up to that spot. So I'm going to look for the one where the dot is. Uh-oh.
Oh, it's
It's
120.
clock. It says
Oh, I'm
clockwise.
wrong. It's 120.
It's rotated 120 in a clockwise direction, which is this way. Uh-oh. Oh, see, I thought counterclockwise. In math, counterclockwise is conventionally positive, but they say clockwise.
No. No, it's this one.
Yeah.
Yeah,
So clockwise is this way, right?
right.
The other way is positive. This way is negative and clockwise. So the dark circle goes to here. The dark thing goes to here. So we look at this guy or this guy, and then which one has see, we need to look at the one where this goes to here. Then the one further to the left goes to above. We're going to look for one with an arrow just above the dark thing. So here's the dark thing. We're going to look for an arrow. An arrow. There's the arrow. There's the arrow. And we want it to be over here. So of these, this is the one that has the arrow.
But it's the one
on the right.
The one I put in green,
Yeah. So we agree.
So
but see, my blunder. Okay, what stuff to watch out for? What stuff you watch out for? They train math kids and mathematicians that positive angles mean counterclockwise rotation. But the SAT question does not mention anything about the angle being positive other than just giving the number of degrees, and they say it's clockwise.
Right.
So you have to think clockwise.
Yeah.
Which is thinking opposite of positive angles that they teach in school.
Right. Okay.
So that's what messed me up.
So yeah,
if I did this on the SAT, I probably would have gotten it wrong.
So let me tell you what messed me up, because I said initially, and I have it recorded, I said this was the answer. What messed me up was that I did 3 ticks I did 3 clicks of this thing. I went 3 clicks. I went 1 click, 2 clicks, 3 clicks. Oh no. 3 clicks is because I saw the 120, and 120 has a lot of 3 to it. 120 is divisible by 3, right? So I did 3 clicks of it. 3 clicks of it is 180 degrees. And then I looked at it. Oh no, it's only 2 clicks. So then I took this little arrow, this little pointy thing here. I did this, and then I went 2 clicks, 1 click, 2 click, and I looked at the only one. There's only one that has this little arrow in that spot, and luckily it is this one. And then immediately no. Yeah. So what I did is I did clicks of the wheel. You have a knob, right? You do 1 click of the knob, 2 clicks of the knob, and then you're done.
Well, I avoided that mistake because I noticed that 1 click was an acute angle, and I knew that 120 is a big angle.
Right. Okay.
It's bigger than 90 right angle, so it's an obtuse angle, and so it's certainly 120 degrees is not one of the clicks.
Right.
And it's might be 2. It certainly isn't 3, because 3 is a half circle.
Right.
Which is bigger than 120 degrees. It's 180 degrees.
But I also caught my mistake because I didn't make it official. As Seth was talking, what I was doing is I was doing it again with another shape, and what I did. See, people don't see
Yeah.
what I do in my thinking, but what I made, I probably caught my own
Yeah.
mistake because I
Yeah.
did right because I did. I played with this one. I went
Uh,
3 clicks of this one. 1, 2, 1, 2, 3,
yeah.
and I realized, oh, my
Uh-oh.
answer, which I said was this one, my answer I said was this one has to have a darkened area over here, and my answer didn't have a darkened area over here. So I said
Mm.
to myself, wait a second, wait a second, wait a second. There's a problem here because this one has my arrow the right way if I go 3 clicks, but this one doesn't. So then I realized, and I realized something was wrong. I got a little scared, saying, "But I know I'm right. I mean, this is so obvious.
Yeah.
It's 3 clicks." And then I realized, I go back. I said,
Uh-oh.
2 clicks, 2 clicks, 2 clicks, and then I realized that I fixed my own mistake. So I probably,
Yeah.
I wouldn't judge. I wouldn't do the question with just one shape. I did it with 2 shapes. That luckily, they didn't give that answer. So basically, when you do these things, it's good to check more than one shape. Maybe, I don't know. That's an approach I certainly did, and it worked
Yeah,
because I
yeah.
caught my own
Well, I
mistake.
realize that you only have to check the you have to check 2 things. The dark segments, and you must check something else because there are 2 symmetric dark segments.
Right.
But then one then I have to check, then I check that the other shapes were distinct.
Yeah.
Yeah. No.
It's interesting though. If this thing was really 3 ticks, if I really went like
Yeah,
one,
three ticks.
2,
3 ticks
3,
would
but then
start. Let fit it. Let me chance that 3 ticks will preserve the position of the of the dark sectors.
3 ticks would preserve the dark sectors.
Yes.
Right, and then this one doesn't. But
Yeah.
3 ticks moves this arrow. The arrow was here, moves it to here.
Yeah.
Well, interesting. I don't know. It's not worth talking about the wrong answers, right? It's not worth beating yourself over like, what's some weird thing going here that I don't quite understand because the 3 ticks is 180 degrees.
Yeah.
So 3 ticks should move everything. It should flip everything across the origin, right? So that's what it does here. 3 ticks. 3 ticks does this, right? 3 ticks takes my little arrow that I use as my reference and moves it here, right?
Yeah.
But 3 ticks should also take this and move it here, and this move it here, right? But it doesn't in that answer that I chose.
Yeah.
Isn't that weird? It did take the arrow and move it here, but it didn't take these guys. Oh, it didn't take these guys and make them go on top of each other. I don't know. It needs more analysis.
Let's see. I see. 2 ones that the 2 possibilities. The 2 possibilities. The two possibilities. I'm just checking.
Ooh.
They differ. They differ by a half circle rotation.
Oh, are you absolutely sure we are correct? Because I'm making an observation. Look what else they did to complicate things. Look at look at this. Look at answer A.
Okay.
This one's the middle one, and those 2. There's this line here. Right? They rotate the whole stupid thing. Because on the original one, there's no line vertical. They take the answer, they rotate the whole pie for A and C.
Oh yeah.
Wow, that's oh. Let's make sure we didn't get a mistake on that. Did we? Did
Oh, yeah, they
we're
can't. Oh,
okay?
yeah, yeah, vertical.
Isn't
Yeah,
that they changed? They take the whole pie and they twisted it to make it even
yeah.
harder.
That they turned it by some odd multiple of 30 degrees.
Yeah.
Yeah,
So that, but that answer's still correct, right?
yeah.
Yeah, because
Uh,
look at
God, this
the
is a
yeah,
it's a I think it's more of an IQ visual thinking type question, which is of course is math.
you sure our answer's right.
Yeah,
We don't. I mean, I could look at the answer book, but it does look like it's right.
yeah.
Uh, yeah, boy, yes, this is definitely more of a yeah. Oh yeah, yeah, yeah. Yeah. Okay, okay. Yeah, I think we're right, but yeah. Okay, okay, everyone.
Yeah.
Oh,
Well, in
this is killing me.
The modern SAT, there are questions about congruence or similarity. It's
Right.
not the same thing, of course, but uh, of triangles, and that's a case where you have to match up, which angle in one triangle corresponds to which angle in the other triangle,
Hmm.
and which edge in one triangle corresponds to which edge in the other triangle. And there are questions involving, congruent triangles presented to you in different orientations.
Yeah. Right. Yeah.
Like they'll take a con a triangle like this. Oh, let me make sure I have a pen going. You have a triangle like this. Up, up, up. And they'll say it's congruent to this triangle. Up, up, up. I should make this bigger. So where
Right.
this length is equal to this length.
Yeah.
Which are the corresponding edges? Which edge on the top? Which edge on the bottom corresponds?
Yeah. Use the
Well,
angles. Use the
it's this one.
angles. Right.
Yeah.
Yeah. Use the angles. Yeah. Yeah. As Seth was talking, I was really trying to. I want to make absolutely sure we're right, and I had another way of thinking about why the middle one is wrong. This one's wrong
Mhm.
because I'm so suspicious of them rotating it. It just didn't make me feel
Yeah.
comfortable.
Yeah.
So
Well, it's not a multiple of 60 degrees.
no. I'm just saying
And
why.
your point is, you to get to if you look at the each slice of the pie is 60 degrees wide. 1/6 of a circle, one
Yeah.
sixth of
Yeah.
360 is 60 degrees.
Yeah.
It's also clear 60 degrees is 1/3 of a half circle. But since each slice of the pie is 60 degrees, half a slice is 30 degrees.
No, Seth, that's not my point. My point is I want to see why this is wrong. Do I want to know exactly why this is wrong because I'm a little suspicious of this one.
Well,
So let me know.
why it's wrong
Seth,
is
Seth,
it's because it is it's a rotation that's some odd multiple of 30.
Seth.
And look at the number 120. 120 is an even multiple of 30.
Yeah.
Right? 120 is 4 times 30.
Right. Oh, so you're saying anything? You're saying anything that has a vertical line here has to be wrong.
Yes.
It has to be wrong. Oh, right. I see what you mean.
Right.
In other words, you can immediately then, if you're smart, you can immediately throw these guys out
Yeah.
because the vertical line cannot be, because the lines have to be preserved. The lines have to be preserved. The fact that the lines cross like this has to be preserved.
Yeah. Why do they have to be preserved?
Right. Why do they? That's a good question. They have to be preserved because they are broken up into 60-degree sections, and it is a 260-degree click. So these lines have, the location of these lines has to be preserved. If you change these lines to look like this, like this, then that can't be right.
So what you're saying is the edges of the pie slices are separated by multiples of 60 degrees.
Right. Yeah. So that
so again, the general logic is that, number one, in order to get a vertical line after rotation, the rotation must be, again, some odd multiple of 30.
Right. Yeah.
But the rotations, again, the rotation that they're asking you to use is 120.
I know. Yes.
So we have to think that 120 is 260s.
Right.
Which is pairs of 30s.
Yeah. Right.
So it's an even multiple of 30.
So then I realized that wow, I was really going down the wrong path there, because I was trying to justify how this could possibly be right. On the other hand, once you realize it, there's no way that you could have a line be vertical here.
Yeah.
Impossible. Now, what did I know? I just do, and what was Seth sort of doing is, we didn't just do this question, and this is one thing you should consider doing it really on every math question and in everything you do, and particularly on tests. Really, look at it and understand what's going on, and doubt yourself, and really get an understanding as to what is really happening. Question yourself, oh, maybe I did it wrong. What's really understanding? What are the different aspects? What are the different facets of the problem? And then you really get some really good insight into the problem. So don't just do a problem. I mean, of course, most people are just going to do the problem, they can go on, right? But really think about all the facets of it, like we're doing. Try to do some of that. Also makes the problem sort of interesting. You really beat it down and explain why isn't one an answer right, and look at it from different points of view. So that's what we're sort of modeling here. Right? Does that helps in doing math? Because Seth has a PhD in math. And so he must have done all that, right? Really look at problems from different facets, and really not stop till you really understand everything about the problem, right?
Yeah.
So that's the approach we're trying to also show. That's why our videos are so ridiculously long.
All right, so I think we're
We're seriously done. We're seriously done here. Okay, everyone, have a great day. Hope that all this stuff helps, gives you some insight. And please like us, dislike us, give us comments on our YouTube videos, or email us at satmathquestionoftheday@gmail.com. And if you have any questions, SAT questions, we'd be wonderful to try them out. Email them to us at the same email address, satmathquestionoftheday@gmail.com. Take care, everyone. Have a good day.
Bye-bye.